FastMCP3's argument transformation mechanism enables dynamic schema modification through the ArgTransform class, allowing developers to hide sensitive parameters and inject default values while maintaining clean client-facing interfaces. This pattern leverages configuration dictionaries to specify transformation rules, supporting both static defaults and factory functions for runtime value generation. We're about to examine two concrete implementations of this pattern. One using a constant default value for an API key, and another employing a Lambda factory to generate unique request identifiers dynamically. The code demonstrates how these transformations integrate with FastMCP's tool system while completely abstracting the hidden parameters from client visibility.
From FastMCP Tools Tool Transform, import ArgTransform. Hash hide with a constant value. Transform args. API key. ArgTransform hide equals true. Default equals secret key. Hash hide with a dynamic value. Import UUID. Transform args. Requested. ArgTransform hide equals true. Default factory equals lambda. Struid UUID 4.
This code demonstrates two variations of argument hiding in FastMCP's tool transformation system. Both examples use ArgTransform to conceal sensitive or internal parameters from client-facing schemas while ensuring the underlying function receives the required values. The first approach hides an API key argument with a static default value, using hide equals true and default equals secret key. This is suitable for constant values like API keys or configuration tokens that shouldn't be exposed to clients, but remain fixed across invocations. The second variation handles dynamic values through default factory, generating a unique requested for each call via UUID, UUID 4. This pattern is essential for traceability or idempotency requirements, where each invocation needs a distinct identifier. The key design consideration here is the mandatory pairing of hide equals true with default factory. This constraint exists because hidden arguments must have their values injected by the system rather than provided by clients. The framework enforces this by requiring dynamic defaults to be hidden, while visible arguments must use static defaults compatible with JSON schema representation. This separation ensures client-facing schemas remain valid, while allowing server-side injection of sensitive or dynamic values. Let's break it down.
From FastMCP Tools Tool Transform, import ArgTransform.
Imports the ArgTransform class from the FastMCP Tools Tool Transform module, which provides functionality for transforming tool arguments in the FastMCP framework.
Transform args equals.
Initializes a dictionary named transform args to store configuration parameters for component transformations. This dictionary will likely contain settings that control how tools and components are modified as they flow through the transformation pipeline, such as hiding certain arguments or applying specific modifications to tool schemas. The empty braces indicate it starts as an empty collection, ready to be populated with key-value pairs that define the transformation behavior.
API key. ArgTransform hide equals true. Default equals secret key.
Applies an ArgTransform to the API key parameter, hiding it from the tool's schema while setting a default value of secret key. The client won't see this argument in the interface, but the underlying function will receive the configured default value.
Import UUID.
Imports the UUID module from Python's standard library for generating universally unique identifiers.
Transform args. Requested. ArgTransform hide equals true. Default factory equals lambda. Struid UUID 4.
Creates a dictionary entry for requested in the transform args dictionary. The value is an ArgTransform object configured to hide the argument from the tool's schema, and generate a default value using a lambda function that creates a new UUID string. This ensures each request gets a unique identifier that clients cannot see or modify. FastMCP3's argument transformation mechanism provides a clean way to manage sensitive or internal parameters through the ArgTransform class. The pattern uses configuration dictionaries to specify transformation rules, allowing developers to hide parameters from client-facing schemas while ensuring the underlying functions receive the required values. The two implementations shown demonstrate this flexibility. One uses a static default for constant values like API keys, while the other employs a factory function to generate dynamic values like unique request IDs. Both approaches rely on the hide equals true parameter to conceal the arguments from clients, with the key design constraint being that hidden arguments must have their values injected by the system. This separation ensures client-facing schemas remain valid while allowing server-side injection of sensitive or dynamic values, maintaining both security and functionality.
The client's empty hands hold secrets, while UUID lambdas whisper keys into the server's ear.